In this video, we're going to look at special examples where perhaps not both solutions we come up with, even though we've done everything right, don't necessarily work in the original equation. Now, again, your first goal in all of these is to get the absolute value part by itself, which in this case, we have done that, or that's already done. The absolute value is by itself. So then, the bit of the tricky part of this is that we also have a variable on the other side instead of just the number. So how to handle that, we're going to look back at the two examples we did on the previous video and look at once we've got the absolute value by itself, what we did next was set that part that was inside equal to both this number and the opposite of that number. So we're going to use that information to help us with those next two examples. Same thing here. We set the part that was inside the absolute value equal to this number and the opposite of that number. Okay, so we're actually going to set up two separate equations for these. So when we do this, we're going to take that part that's inside the 3x plus 2, we're going to set it equal to this. And we are also going to set it equal to things got a little bit of a delay, so we'll try to work with that. Or we're also going to set it equal to the opposite of this, 4x plus 5. Okay? So that's how we're going to handle that. And we're going to solve each of these equations, these two equations, individually. So what we're going to do, let's solve this one first. And to solve this one, we're going to get the x on one side and the constants on the other. Kind of combining two steps there. So what we end up with is negative 3 is equal to 1x. So we're done with that part. In this one, we're going to distribute this negative first, so we have 3x plus 2 is equal to negative 4x minus 5. So then what we're going to do is get the x's on one side, the constants on the others. So we're going to add 4x. I always like to make sure I move the x term so that it stays positive. Again, really doesn't matter. If you wanted to subtract the 3x, you certainly could. Or if you wanted to subtract the 4x here, you certainly could have done that. Okay, so in this case, we're going to move the constants to the other side by subtracting 2 to both sides. So on the left side, we're left with 7x. On the right side, we're left with negative 7. So then x is equal to negative 1. So x is either equal to negative 3 or negative 1. Now, we are going to test both of these. So in the check, we're going to check negative 3 first. So we're going to plug negative 3 in for each of those x's. So on the left side, 3 times negative 3 is negative 9, plus 2 is negative 7. The absolute value of negative 7 is 7. And then when we plug negative 3 in for x on the left side, we have 4 times negative 3, which is negative 12, plus 5, which is negative 7. Well, the problem here is that 7 is not equal to negative 7, so therefore negative 3 does not work. It's not a solution because it doesn't work in the original equation. Okay? And in this case, we've done everything right, but it still doesn't work in the original equation, so therefore we call that negative 3 an extraneous solution. That's why those directions at the top of this worksheet say check for extraneous solutions, because even though you've done everything right, it still doesn't work in the original equation. So checking these is vital. We better check negative 1 also. If we put 3 times negative 1, that's negative 3. Plus 2 is negative 1. The absolute value of negative 1 is 1. So on the left side, we end up with 1. Is that equal to what we end up with on the left side when substituting negative 1 in for the x? 4 times negative 1 is negative 4. Plus 5 is 1. 1 is equal to 1, so therefore negative 1 is a solution, and that is our only solution. You need to make sure you check both of them. Now, doing the same thing with example F, we are going to set part inside equal to this value, 7x plus 14. We are also going to set it equal to the opposite of 7x plus 14. Okay? Again, doing what we did before, it's just that now, since we have those two x's, you can't really set it up in just one three-sided equation, we'll call it. You need to separate them into two because solving them will look quite a bit different. So we'll solve the one on the left first by subtracting 5x from both sides and subtracting 14 from both sides, getting the variable on one side, constant on the other. And again, I like my x terms to be positive, so that's why I moved the 5x instead of the 7x. We've got 2x is equal to negative 16, so x is equal to negative 8. And then on the right side, we need to distribute the negative first, so 5x minus 2 is equal to negative 7x minus 14. And then we're going to get the variables on one side, constants on the other, so we're going to add 7x. Again, keeping that positive, and then we need to add 2 to get the constants on the other side. So once we do that, we have 12x equals negative 12, so x is equal to negative 1. So x can either be negative 8 or negative 1. It could be both. That's why we need to check. So now for the check, we'll start with the negative 8. 5 times negative 8 is negative 40. Minus 2 is negative 42. Absolute value of that is 42. Is that equal to what we end up with on the right side? 7 times negative 8 is negative 56. Plus 14 is negative 42. These two are not equal, so therefore negative 8 is not a solution. Now, we didn't do anything wrong when solving this for x, but it still doesn't work in the original equation, so you have to check these. All right, then the second one, we'll check negative 1, substituting it in for x. 5 times negative 1 is negative 5, minus 2 is negative 7. Absolute value of negative 7 is 7. On the right side, 7 times negative 1 is negative 7, plus 14 is 7. These two are equal, so therefore negative 1 is our solution. Sometimes maybe neither one of them will work, in which case you have no solution. That can happen also. But in these, you need to check, because you're going to do everything right, and it's possible that one of them won't work. So make sure you check those solutions. And once again, those solutions where we have do everything right, it's a possible solution, but it doesn't work in the original equation, are called extraneous solutions. And that is the last video for today.